I'd like to do a summary of the addition and multiplication rules, and to do that I'm going to use this table of blood types and RH factors. You can't be O, A, B, or AB, or one or the other, and you're either positive or negative. So we have 409 participants, and we have it broken down in a what we would call a pivot table in Excel as to how many we have of each. So now if we're talking about the probability of O, we're just looking at how many total O people we have, which is 184 out of 409. So that's pretty straightforward, and we can do the probability of A, the probability of B, we can do the probability of positive. Now we're looking at the total in the row, which is 344, oops, this is a 9, out of 409. Okay? Now when we talk about and, we're talking about independent sequence of things. So what we're saying is, what's the probability of O followed by and also getting in the second person being a B? Well, when we're doing and, we're doing multiplication. So the probability of getting an O person is 184 out of 409. And then getting a probability of a B person, since these are independent samples, independent groups, you can't be O and B at the same time, we have 45 out of 409. And we're going to multiply these two fractions. And that's going to give me the probability of getting an O person and a B person. Remember, that's a sequence. Now, if I take O and positive, in this particular case, I'm looking for a person who's O and a person who's positive. Well, that's also multiplication. It's the probability of an O and the probability of positive given an O. Well, in the table, though, that's pretty much done for us, because probability of O and positive is limited to 156 people. So the calculation has basically been done for us in a table, and 409. Now when we get to the OR, things change a little bit. OR is the addition rule. The probability of O or B, these are mutually exclusive. Okay, they do not have any, they can't be in common. So when we do the probability of O, we can say we have the probability of O, which is 184 out of 409, plus the probability of B, which is 45 out of 409. Now notice the difference. When I'm doing a probability of O and B, I'm talking about two people that I'm looking at in sequence, picking one and then picking the other. When I'm doing an OR, I'm saying that one person, what's the probability that that one person has either O blood or B blood? Different meaning. O or positive. Now this one gets a little tricky because these are not, O and positive are not mutually exclusive. So I start out with O, which is 184 out of 409, plus the probability of positive, which is 344 out of 409. Now you can see that if I just add these together, I'm going to be over 409, which 409 over 409 would be 1, and the probability always has to be less than 1. And because they overlap, you'll notice that the 156 is in the total 184, and the 156 is also in the total 344. So therefore, I need to subtract out a duplicate. So 156 over 409. And do that calculation, and you will have the probability of O or positive. Now, what this says is the probability of O given that a person is already positive. That means that the probability of O, given that a person is positive, that means we're only looking at the set of positive numbers, positive values. So that's 344 for the denominator, and the numerator is how many O's out of that, which is 156. Okay, I'm going to do it in reverse. Given positive, find the probability that someone is positive given that they are an O. Given that they are an O, we're only picking from the total group of 184 people, and positive is 156. I hope this helps you to better understand the different probabilities that can come from a table. Thank you for watching.